Hello and howdy, my fellow mathletes. Root Beer here, looking at question 20 on our 2019 Fermat paper. The vertices of an equilateral triangle lie on a circle whose radius is 2. The area of the triangle is... Okay. So for this question, well, let's first imagine our equilateral triangle. I'm going to draw the circle first. Put the triangle in. Okay. How do you find the area of a triangle? Well, you need to know things like base and height. Now, when it comes to equilateral triangles, there's a very nice little formula. So if the side lengths are x, all the sides are x. And if it's equilateral, you get a 60 degrees in here. If you split the base in half, it's isosceles, so dropping a perpendicular splits the base in half. You can see you're going to have a 30, 60, 90 triangle. 30, 60, 90 triangles are quite well known. They come up on contests a lot. They have ratios in the side 1 to root 3 to 2, with the 1 being opposite the 30 degrees, root 3 being opposite the 60 degrees. So this triangle, this half of my equilateral triangle, is just that, but scaled up a little bit. So here's the side opposite the 30. So we go from 1 to x over 2. We'll go to root 3 to root 3x over 2. And that's a great way to find the height of equilateral triangle. And of course, we already know the base is x. So the area of an equilateral triangle is just 1/2 base times height. And this is more well known as root 3x squared over 4. It's a nice little formula. If you don't know it, well, there you go. But how's that going to help us here? Well, imagine our triangle. We know that we've got a circle. Its radius is 2, and the vertices are on the circle. So if we connect them up, we get these nice 2's here. Okay, fantastic. How's that help us? Well, it's a nice equilateral triangle. By symmetry, we can see these angles in here are going to be 120. Okay. We've got isosceles triangles. Now 120 plus 60 makes 180, so the remaining 60 inside this triangle is split between these two. So we get some more 30-degree triangles here. Okay. So what else could we do? Well, you could probably at this point use the cosine law to figure out the side length of the equilateral triangle and then plug that into the formula here. But I'm going to do something a little different. I'm going to drop a little perpendicular down the side here. And now, thanks to the 30 degrees we have another 30, 60, 90 triangle in here. And we've got a 2 for the hypotenuse. So the length opposite the 30 should be a 1, and we should get a root 3 opposite that. So half of the side here is root 3, so that means the whole side of my equilateral triangle must be 2 root 3. So now I know the side length. Well, there we can plug it in. We didn't have to actually use any trig there, which is always nice. I try and avoid trig, busting out things like the cosine law and plug in. I like to use geometry where I can. But root 3, now we need x squared, so that's 2 root 3 squared all over 4. Now the 2 squared and the 4 are going to cancel out. So we'll get root 3, and then the root 3 still gets squared in here. So that's going to be 3 root 3. So that's going to be the area of our triangle. There we go. So 3 root 3, is that one of the answers? Yeah, it's lying right there, waiting for us to be bubbled in. It's A. Okay, so up next, we're going to be starting the last 5 questions. We'll be doing question 21 in the next video. These are the Part C questions. They're worth 8 marks. They're meant to be a little harder. So if you haven't taken a look at them already, I would strongly encourage you to do so. Take a look at questions 21, 22, 23, and then feel free to come back and join me as I go through them there. Okay? Until then, take care and have a wonderful day.